we will be talking about other digital tools for use in the construction industry for this series of lectures, including talking about wearable technologies or construction wearables, the Internet of Things, and 3D printing or additive manufacturing. Now, you can see the picture here shows the worker that is wearing different types of construction wearables. For example, a smart hard hat, smart monitor, power glove, smart boots, smart watch, AR safety goggles. We'll be talking about this in more detail in the next few slides. But how does the construction wearable actually works? Well, it works by adding new technologies to existing safety gear. These construction wearables enable new features like monitoring of vital signs, say heartbeat, detection of collision or possible detection of collision, and also tracking of lone workers that could be working in a hazardous location. Now, what are the benefits of construction wearables? Well, the construction wearables can help to reduce fatal injuries on the worksite. Wearable technologies could also help to prevent falls, which account for almost 1/3 of the construction industry, typically in the US, and also just as much in the Singapore setting. Construction wearables are devices generally including a computer or advanced electronic device worn on a construction worker's body, clothing, or personal protective equipment. They are designed to collect and deliver data about the worker's environment, the activities itself, or biometric conditions. The technology has the ability to detect and to warn the employee of the potential for injury, or to reduce the seriousness of an injury if one should occur. Objectives are achieved by providing portable and timely access to sensors, computers, and electronics. The industry's emerging access to multifunctional technology and its ability to collect and analyze relevant data is revolutionizing the way we protect our workers. There are different types of wearables that can be used. Visual wearables. These are devices that could use optical aids in or on glasses, visors, and hard hats to produce image for remote viewing and or the wearer. Visual wearables can bring value to training, troubleshooting, quality control, and other situations where visual representations of a concept is needed. This type of wearable connects few employees or workers to remote technical supervisory employees, allowing both parties to view items simultaneously. Sharing visual information overlaid on actual work environment can enhance instruction, training, and verification of practices and materials. Another benefit of this type of wearable is that few workers' hands remain free to work while they are discussing solutions or working through an issue. Another type of wearable is what we call tactile wearables. These are devices that work as an exoskeleton to increase the user's strength and durability. Tactile wearables are designed as exoskeletons that provide extra strength or endurance to the wearer. They also limit the force on the wearer's muscular skeletal frame. Force is constantly monitored and the wearable responds to protect the worker. The potential for strain, sprains, and back injuries can be reduced while simultaneously increasing the worker's capacity and endurance when they are wearing this type of tactile wearables or exoskeletons. Another type of wearable is a sensing wearable. These are devices that can sense the worker's biological, environmental, and physical conditions. In addition to sensing conditions, the device analyzes data using edge computing and warns the worker of hazardous situations that potentially can lead to an injury. The sensors come in many forms. It could be badges, actuators, biosensors, gyroscopes, and more. They record and evaluate the wearer's physical condition, location, and environment. These wearables can sense location, impact, motion, temperature, vital signs, blood gases, and evaluate and interpret the data to provide actionable information. The sensors can also be deployed in numerous configurations to make wearing them simple, easy, and unobstructive. Methods of deployment can include attachment to hard hats, safety glasses, or personal protective equipment. Clip-on wearables can be attached to shirts, vests, and belts. Edge computers can be contained in wristbands or clip-on devices. Wearables can also be embedded to the soles of shoes or worn as insoles. Let's look at some of the wearables, starting with the smart watches, which sometimes can be called a safety companion on the wrist. These are some of the features on the smart watches. It can monitor health and activity, it can detect falls and send alert, and it enables hand-free communication. Many people now wear a smartwatch daily, but the powerful sensors in products like the Apple Watch have special significance in the construction industry. These devices are capable of monitoring activity data, detecting falls, and enabling safe communication. For example, it can actually look into health and activity data. The contractors and workers can monitor vital signs like heart rate and step counts to prevent over-exertion. And some products are even capable of recording an electrocardiogram to detect abnormal heart rhythms or blood oxygen saturation to spot respiratory distress. It can detect falls. Falls are the leading cause of injury and death on construction sites in many countries. And new wrist wearables are capable of detecting falls and immediately alerting site and emergency personnel, speeding up response time when accidents do happen. Safety communication. Workers need their hands free, especially when operating equipment, and smartwatches enable them to communicate without needing to use their hands at all. In addition to these benefits, construction wearables may soon help monitor mental health of construction workers, which is a growing concern in recent years. Products like the Mood Beam 1 promise to help workers keep track of their mood throughout the day and spot workers that is having mental health issues. Let's look at another type of wearable called the smart boots. These are the smart boot features. It can detect pressures from shock and falls. It can sense the location where the worker is in, and it can self-charge simply through the worker walking from point to point. When workers are wearing the smart boots, they will be able to see that their boots, which is already an essential piece of safety equipment, you'll see that their boots are transformed into a powerful piece of wearable technologies that is capable of detecting pressure and location, all without the needs to be regularly charged. That is because smart boots typically comes with pressure detection system and capability. With sensors equipped in the soles, the smart boots can detect falls or small shocks sustained by construction workers and call for help automatically. It can also allow for location sensing. Many construction wearables are location aware, and smart boots are no exception. Using technologies more sensitive than GPS, smart boots can track the location of a worker accurately, which improves lone worker safety and help to reduce time spent in unsafe areas. And the smart boots typically will come with inbuilt charging capability. With charging technologies located in the heel, smart boots can be charged simply by walking, increasing the chances that the boots will stay charged throughout an entire shift on the worksite. Products like Smart Boots by Soul Power are aiming to revolutionize construction footwear in the coming years. Let's look at Smart Hat or Smart Hard Hat. The features of the Smart Hard Hat includes allowing the monitoring of fatigue of the workers, preventing micro-slips, and detection of collision. Hard hats are a vital piece of safety equipment for every construction site. But new features found in the Smart Hard Hat will make them even more indispensable. By adding a sensor band around the inside rim of a hard hat, technology companies aim to create a construction wearable capable of detecting fatigue, preventing micro-slip, and sensing proximity. In terms of fatigue detection, by measuring vital signs, the smart helmets are able to detect worker fatigue and signal the need for a break. With powerful technologies that evaluate brain waves, a sensor band that sits in the inside of a hard hat can detect micro-slip before they occur. Micro-slips, which are sudden movement of sleep that occur in fatigued individuals, are especially dangerous for construction workers that is working in a hazardous environment. Smart hard hat can also allow for proximity sensing. With sensors in heavy equipment and hard hats, construction wearables can help to alert contractors, workers, and equipment operators to potential collision, helping to prevent accidents. New technologies included in products like Smart Cap and Weight Cap will add these features to the construction helmets on more construction sites in the coming years.